Next, now if you talk about the types, this is important. Most commonly in India or in Gulf, you'll find cooling only model. But we have three options. We have three types. First is a cooling only. Second is a heat pump. And third is a heat recovery. So the cooling only means you can understand it is used for only cooling, like a split system or what we discussed till now, like package or VRF means only for cooling point with the temperature means in summer, like in India and Gulf. But here the next type is a heat pump. So remember, heat pump we can use for cooling or heating, but not simultaneously, any one at a time. For example, one outdoor is connected to 10 indoors. So all 10 indoors we can use or we can call for only cooling, or all indoors, all 10 indoors we can call for only heating, not say partly cooling, partly heating. For example, in summer we are using all indoor for cooling. In winter we are using all indoor for heating. This is heat pump, but how exactly, we have a detail with the line diagram. Next, we have heat recovery. This you see, this cooling is a simple version of VRF, but heat recovery is an advanced version of VRF. In that, you'll find heating and cooling simultaneously, or you can go for only cooling or only heating as per the requirement. Take example of a hotel. In hotel room, one customer is calling for cooling, and in other room is calling for heating. So this can be achieved with the heat recovery VRF type, VRF system. But how exactly, we'll discuss in detail. Cooling system you can understand easily. In heat pump you'll find 4-way reversing switch, and in heat recovery, the advanced type, you'll find 3 pipes. You see, point 1 and point 2, cooling only and heat pump is a 2-pipe system, and the heat recovery is a 3-pipe system. We'll discuss in detail. So what I explained, the same in the images. You see, first cooling only, one outdoor, connect with the 4 cassette type FCU. It can be more than that, but it can be of different types, different capacity, and all are cooling, all calling for cooling. This blue or shade of blue represent cooling. Second, you see heat pump, one outdoor, connect with the multiple indoors. It can use for cooling or heating, any one, not both at a time. Next, heat recovery is advanced. You see, 2 call for cooling, 2 call for heating. Or else we can use all for cooling or all for heating in heat recovery mode. So we have a lot of options of flexibility in heat recovery, but at the same time it's a complex system and expensive also compared with the other 2 types. So now we'll discuss of all these types with detail. First, which is commonly in market in Indian market as well as in Gulf, which is a cooling only VRF. Okay, so to understand this concept, I have given this line diagram. This is simple. We already discussed about the split system now, similar to that. But the new thing is, you see, the concept, vapor compression refrigeration cycle, the same concept. So what are the components in outdoor? Compressor and condenser. But the new point here, you'll find inverter scroll compressor. You'll not find the other types in the VRF, inverter scroll, or it can be a digital scroll, the 2 types. And apart from this, you'll find this EEV, electronic expansion valve, and rest of the concept is same like split. Assume that this outdoor is of 6 TR and this is indoor 1, say high wall. This can be cassette and this also high wall, or it can be a same type, whatever. Just I'm giving the idea because we can use the same type or it can be different type. So 6 TR means, for example, I'm considering this is 2 TR, this also 2 TR, and here also 2 TR. It can be here 3 TR, then 4, 5, 6. It can be 3 TR, 1 TR, 2 TR. It can be different as per the required capacity of different spaces. Suppose this is in room 1, this is in room 2, this is in room 3. Depend as per the requirement. So you see, the cycle starts from the compressor. This cycle, compressor, then condenser, then expansion, and evaporate. And the important point here, in a split system, in the new models, this, the expansion is in outdoor unit, right? But in the VRF cooling only model, you'll find expansion in indoor only. because we have multiple indoors now. You cannot place this expansion in the outdoor unit. This is one point. And the expansion is of automatic type. So you see electronic expansion valve. And this electronic expansion valve have a communication cable to this outdoor control microprocessor control unit. And this microprocessor control unit have a link with the VFD, and this is having link with the compressor. So it's a complete with the control system. It's not just simple one. In the outdoor, if you open the outdoor of VRF, you'll find a big motherboard like in PC. You'll find the motherboard, that is a small one. So you'll find a big motherboard. You'll find the control processor, a lot of things, and that is used for the communication between the indoor and outdoor. So electronic expansion valve have a communication cable to this outdoor control microprocessor control unit, and that link with the VFD drive, and the VFD drive link with the compressor. So what will happen? For example, all these 3 rooms machine is on, for example. So the compressor will run at a full load and supply the refrigerant to all this indoor unit, and this all expansion electronic expansion valve is fully open. After say 15 minutes or half an hour, room 1 attain the temperature. And you know this, already discussed now. You'll find the thermistors and you'll find a bulb at the evaporator side. That same example at the time of window AC. So you know all these units control the compressor by what? By return temperature. Na? For some time the return temperature is same as what you set. For example, in room 1 I set say 23 degrees centigrade. After some time in the return also 23. So this sensor, nothing but the thermistor, that bulb, will continuously monitor the return temperature and give the signal to this electronic expansion valve. And this electronic expansion valve have link with the outdoor unit with the communication that we used to call communication cable, nothing but a cable which is used to send the signal. So if the temperature is attained, what will happen? The electronic expansion valve will close, or as the temperature decreases in the room, it will start closing. And when the temperature attains, it will assume that it's completely closed. And this is sending the signal to this outdoor unit. No? And according to that, automatically the compressor speed will reduce. And reducing the compressor speed will reduce the flow of refrigerant, no? Or the volume of refrigerant. So we used to call this system as VRF or VRB. Yeah. Okay. And the same thing happened as per the load demand inside the spaces or inside the building. Okay, very simple concept. But this can be achieved precisely with the control units. Within seconds, the compressor must reduce the speed, or else if the pressure in the line increases, means what will happen? The system may fail, the leakages. So this is a precise type of system. Even the commissioning on site, they will do with the software. So precise control is required, and the length of the pipe, even the pipe sizing, we have a complete procedure for pipe sizing, and that too again a software base. We have a separate topic for pipe sizing for this. And you'll find the rough net, nothing but rough net means, for example, here is outdoor. From the outdoor, this line connect to one indoor, and the line will continue. So this fitting is called rough net, REFNET, rough net. We have another name also. You'll find in the next page. Most commonly in actual practice, we used to call this fitting as rough net. Again, it will continue. Again, you'll find the fitting, and this will connect to another indoor. This will continue. So this is a rough net. So I'll show you one drawing also, in that you'll find more details. At this level, just I'm giving the idea about the concept, how the system works. Okay. So I think you got the idea how this cooling only VRF system works. Next, we have few points to discuss. Then we'll move to the heat pump VRF system. You see this cooling only, this is only for cooling. Variable speed crawl compressor, as we discussed. Simple version of VRF compared with the heat recovery type. Next, commonly used in India and Gulf region. Next, it uses EEV, electronic expansion valve. And according to the requirement, it will operate. It can on and off, or it can modulate. Next, communication cable between this EEV and the control unit of the outdoor. And energy efficient compared with the split of a normal compressor. And apart from this, we have list of other advantage that we'll discuss all together after completing all these three types. Okay, so this is only for the cooling only type. Next, we have a heat pump, VRF. This is an interesting concept. You see, the term heat pump we are using for vapor compression cycle to use that cycle in reverse order. Na? So if I use the term heat pump means I'm talking about the vapor compression cycle, but in reverse order. The condenser will change to this evaporator, and the evaporator we are using as condenser. Means inside you will find, in indoor unit you will find what condenser, in outdoor unit you will find evaporator. If I talk about only heat pump, but here we are talking about heat pump VRF. So remember, heat pump VRF is for cooling or heating, but not simultaneously. This is important. Compare with the next heat recovery type. So I can use only for cooling or only for heating for all the units, but not partly cooling or partly heating. Okay, means the cycle can reverse. How exactly? I'll show you. This is interesting. And it uses four-way reversing valve and NRV. So how exactly? This line diagram will help you. First, let me explain this in cooling mode. Then we'll discuss how this system work in heating. So you see what we discussed in now, the same is applicable here. We discussed this in cooling only, now one outdoor, multiple indoor, and electronic expansion valve. The same thing you can find in this heat pump also. But how exactly it will work for cooling only or heating only, that we need to focus. So here on screen, you see at this level, first I'm considering this as only cooling. So you see this blue color represent that is for cooling. Okay, now I'm going to, and you see this is four-way reversing valve, this one. In there you'll find four valves. So first for cooling mode, I'm going to switch off. I'm not going to switch off. It will means if this two valve will close. If I use in heating mode, then this two valve will open, this will close. And apart from this, for all indoors, you'll find NRV. And I believe you know what is NRV. It's a non-return valve, right? Rest of the thing is same. So first try to understand this heat recovery VRV or VRF in cooling mode. Okay, as I said now, any one mode at a time now. So first cooling mode. So in cooling mode, you see this valve 1 and 2 in close position. I'm writing here close C and C. C refers to close. This is going to be close and this 2 is going to be open. Automatically, this will happen automatically. We'll not do manually. The valves on and off will do automatically. We can change the mode. That can be manual. But this operation is going to be automatic. So you see what will happen. You know, the cycle start from the compressor and the same scroll, inverter scroll compressor in this case also. What we discussed till now, the same thing is applicable here. You see the refrigerant start from the compressor, you know, and after that it will pass through this valve because this valve is open and this is closed. And after this, it will enter in what? Condenser. You know the cycle. And what happened in condenser? I think no need to explain. So after condenser, the refrigerant will enter through this NRV. It will not enter in this electron expansion valve. This is used for the reverse cycle. We'll discuss next, means for heating. But for cooling, remember, this valve, this electron expansion valve is totally in closed position. So it will allow to pass through a bypass line with the NRV. Okay, so refrigerant will pass after this condensation, the refrigerant in liquid form. The liquid form is allowed to pass through a bypass line with the NRV. It will not flow through this EV. This is going to be enclosed because we are talking about the cooling mode. Next, the refrigerant, you know, the refrigerant liquid form, it will enter. Now, you see, this is indoor 1, indoor 2, indoor 2. In room 1, room 2, room 3. And this may continue like 10 units, 20 units. Just for example, I consider 3 units. So you see, it will enter through this electron expansion valve. The same what we discuss in the cooling mode only. And this bypass line is for heating, next part. So ignore this. So it will pass through the electron expansion valve. You know what will happen in expansion valve, and the refrigerant with the low pressure and temperature, it will enter in the evaporator and the return. The same from this unit 1, from unit 2, from unit 3. And you see the complete return from this line, you can check. This valve is closed, so this valve is open, so it will pass through this open valve and again enter in the compressor. In between, you'll find the accumulator, which is used to separate the liquid and vapor, etc. That the same thing. So in this way, it will work in cooling mode. I think no confusion, right? Now we'll discuss how this will work in heating mode. Okay. So for heating mode, let me change the color. I'm using this red color. So now you see, in heating mode, this valve and this valve in closed position, this is going to be in open position. The cycle starts from the compressor only. You see the refrigerant, compress refrigerant with the high temperature and pressure through this line, it will reach up to this point. Now after this point, this valve is closed. So it will enter in this through this valve to this line now, and this valve also close. So you see what will happen. The direction of flow is here. This direction is for cooling. Now the reverse cycle now. So you see here the high temperature and pressure refrigerant now is entering directly in the indoor.
Evaporating.
And this will become condenser now. In general, you see, in general, this in this unit we can call heat exchanger. We are not giving the name as evaporator or condenser because the cycle can reverse na. In cooling only we can say indoor evaporator, outdoor condenser, but in heat recovery or heat pump, or even in heat recovery, we can call this as a heat exchanger because this will change. So now this will become condenser. Why? Because you see the hot refrigerant with high temperature and pressure entering in that heat exchanger means this will become condenser na? And the room temperature is low in because we are using in winter, because I'm talking about the heating mode, right? So room temperature is low, and when the air is thrown on this, the room is this refrigerant loses the heat to the room air, and the refrigerant changes phase from vapor to liquid, and at the outlet you'll find same cycle but reverse. So you see, you'll find the refrigerant in what? Liquid state. Now the refrigerant, it will not pass through this electron expansion valve. This is used for cooling. And remember, this electron expansion valve in heating mode is going to be closed, like this valves. This is all in closed position. So it will, if it is closed, means we have a bypass liner with the NRV. So it will flow in only in one direction. So refrigerant within the liquid form through this bypass line, you can see the direction, and same for all these three. Now you see, now it will enter in this electron expansion valve, where it loses its pressure and temperature. Then this will become evaporator. Getting a point? Next, we have next advanced type of VRF, that is a heat recovery. But before this, some quick points on the same cooling or heating. What explain for reversing. Advantage, disadvantage we'll discuss at that. Next, we have a heat recovery VRF. This is an advanced type, what I said. And in that we have three options possible. We can use only cooling mode, we can use only heating mode like heat recovery, plus cooling and heating simultaneously as per the application demand. And this can be best suitable for the hotels, because in hotel rooms, as per the requirement, as per the space requirement, one can call for cooling, one can call for heating as per the requirement. So this option is good for the hotels especially, not for offices or residential. Okay, depend as per the client requirement also. So to understand this, mode by mode we'll discuss. First, let me explain cooling. This is going to be easy. Then heating, then cooling plus heating. If you talk about only cooling, you see I'm using only cooling mode. You see what we discussed in the heat recovery, the same plus some more additional option. And the first point here in this is a 3-pipe system. Only cooling or heat recovery, sorry, my mistake. Only cooling or heat pump is a 2-pipe system, but this heat recovery is a 3-pipe system. Important for interview point of view. And why we are calling 3-pipe, you can see 1, 2, 3. 3-pipe is to this indoor, but not completely to the indoor, to the branch controller. And you see this roughnet, also known as suppression tube, commonly roughnet, technique you can call suppression tube also. So first point is a 3-pipe system. Now, first we'll discuss how this work in a cooling only only cooling mode. You see, the cycle start from the compressor, the refrigerant in this direction. So refrigerant can flow in the left direction as well as in the right direction. So in cooling only cooling mode, remember this valves is going to be in close position. Close, close, and close. The red color represent the heat. So refrigerant will enter in the left line, but these valves are closed now, so it will not flow. And the refrigerant will now flow on the right direction. And this valve is open and this is close in cooling. And since this valve is open, the refrigerant can flow and it will enter in what this heat exchanger is called condenser, na? Because we are talking about cooling, because this is outdoor. The same thing. And refrigerant enter through this bypass line. It will not enter in the electron expansion valve. This is going to be used in heating only, same like previous. So with this NRV here, now the refrigerant in liquid form is available to this suppression tube or roughnet. Now this refrigerant in the liquid form, it will enter in this line. I'm considering one indoor which demand cooling. At this level I'm talking about cooling, so you can consider this also cooling, this also cooling. You see it will enter, and this valve is open position. Under this branch controller you will find a separate branch controller to which you'll find the number of valves for different indoor units. So this valve is open position and this valve also in open position. So you see it will enter, and it will enter in electron expansion valve, the same thing. Okay, and loses the heat and this pressure and temperature, and it will enter in the evaporator coil. You know what will happen in this room. And since this valve is closed, so it will enter through this valve which is open, and you can see, and this is from other indoors, and then supply back to accumulator here. In other case also you'll find the accumulator. You see in the accumulator, any liquid, it's going to be at the bottom. Only the vapor is going to be sucked by the compressor. You'll find this accumulator even for other units also, which is not shown. Or for learning point of view, this line, you see, it's to the compressor. This is a cooling mode, very simple. No confusion, na?
Yes, sir. Yes, sir. Yeah.
Next, we'll verify this heating mode. Heating mode also you can understand easily. In heating mode, you see the direction of refrigerant. It will go in this direction as well as in this direction. But this valve is going to be in close, and this is going to be in open position. Okay. So this valve is closed means the refrigerant will not pass through this valve. It will stop here. So refrigerant will flow in the left direction. So after compression, you see through this suppression tube, nothing but rough net, it will enter in this, say, unit 1, and all are I'm using heating now. So you see this valve is going to be open. This is going to be close, and this open. Okay. So it will pass through this valve. Now this will become what? Condenser.
Condenser.
Next. So the refrigerant, it will not pass through this electron expansion valve. This also close in heating mode. It will pass through this bypass line with the NRV, then out. And this also from the other ears. And this, now it will enter in electron expansion valve. It will pass through this, and this will become evaporator. And after this, you see, since this valve is open and this is closed, the refrigerant will pass through this and enter in the accumulator, then compressor. This is for heating. And you see, this what we are learning is a concept. In actual practice, this can be achieved with the complete control system. Okay, with the precise control, this is not that much easy. Next, now we'll discuss how the system can use for cooling and heating simultaneously. This is interesting, and why we are calling this as a heat recovery. You see, for example, room 1 call for cooling, room 2 call for heating. So the cooling means the heat extracted from this room can be utilized to provide the heat to this room 2, for example. So what we are doing, we are recovering We are utilizing the waste energy in the other space. So that's the reason we used to call this system as a what? Heat recovery VRF system. We have a separate HRU. I'm not talking about that. That we'll discuss later. HRU, heat recovery unit. That is a different. But this is heat recovery VRF. Why the name is given? Now we'll try to understand the concept. Cooling plus heating mode simultaneously. For example, space 1 cooling, space 2 call for heating, space 3 call for cooling, for example. Now in that case, this valve is going to be in open position. This is in close. Apart from this, see the reference start from here. It will flow in this direction as well as in this direction. So you see after compression, if the refrigerant flow in the right direction, you can expect the cooling. The result is cooling. On the left direction, you can expect the result in heating. Okay. So what will happen? Partly refrigerant will flow in the left direction, partly in the right direction because this valve is open now. So you see the first indoor is calling for cooling. So we'll talk about this refrigerant. Means here the refrigerant is available for cooling and this valve is closed. This valve is open. This also open. The refrigerant will enter and this act as a what? Evaporator. Next. Now this call for cooling now. You see refrigerant flow in the left direction also. So the hot refrigerant here, this valve will open for this unit because this suppose in this room they call for heating. So this valve will open and this is going to be closed and this will open. So the hot refrigerant will enter and this will become what? Condenser, right? And the hot refrigerant, 1 minute. Condenser, it will reject the
Yes, it will lose the heat.
Condenser only. You see the refrigerant, it will not pass through this electron expansion valve. It is bypass line. It will enter. This is open. Now the refrigerant at this point is a what?
Liquid line.
Means after condensation. Na?
Yes, it's liquid line.
So you see it can go back to the unit or else we can utilize for this room 3 which call for cooling. But this can be achieved as I said now with the complete control system, with the opening and closing the valve, with the complete microprocessor. But you see at this point the refrigerant in the liquid state means after condensation. So if this room 3 call for cooling, this refrigerant is available in this. So it can flow in this direction as well as we have option to flow in this because this is demand for the cooling. Na? So the refrigerant in the liquid form, it will pass through this electron expansion valve. You know the process. So this is about the heat recovery. Now you see this is an advanced version of VRF and we used to call this as a 3-pipe system. Cooling plus heating, only cooling or only heating or cooling plus heating can be used as per the requirement. Now if you talk about the advantages overall for the VRF system, we have these advantages. You see efficiency point of view, the efficiency is good compared with the other DX system. What we learned till now comes under DX only. And we have a separate chill water system. But before talking about the chill water I'll give you the points related to the difference between a DX and chill water. But remember what we discussed till now, right from window, all the systems comes under DX, nothing but direct expansion. So compared with the other direct expansion system, the VRF efficiency is higher. Next, we have a design flexibility suitable for various application, and that is very good option for the interior requirement because we can go for the different types of indoor which suits the interior requirement or as per the type of the project. Comfort and quiet again that depends on the type of indoor. Energy saving, what we discuss, and this can be connected with the BMS system in the building. So complete we can do the automation with this. BMS is a building management system. Mostly for big projects you'll find the BMS system which will control the different system. And space efficiency for especially for the outdoor unit compared with the, suppose if you use a split system, so you need to provide space for all the outdoors. But here, since we have one outdoor, multiple indoors, so we have a very good option for space saving, especially in the commercial areas for the outdoor point of view. But we have some disadvantage also. The cost thing is high because this comes under the advanced system. Even if you talk about only cooling compared with the normal split, This is the advanced type, so the initial cost is going to be high. You can compare this at least 4 to 5 times expensive compared with the split system in general.
Ductable split.
No, this compared with the split in general. And installation point of view also, you should be very careful because you see, this is a complete network of pipe, one outdoor connect to the multiple indoors. If the
Yes.
problem in one unit means that may affect to the entire system. But now in market, we have some isolating valves for each and every indoor. By by closing that isolating valve, we can isolate that particular system in case of maintenance or breakdown. But still, it will affect to the system. So installation point of view, and that's the reason most of the project, the manufacturer will also involve in installation, especially at the time of testing, QC, commissioning, etc. As for this VRF type, compared with the other. Next, in
Like
case of leakages, you see the refrigerant loss. In case of leakage from one unit, it may affect to the whole system. Okay, so these are some disadvantage compared with the other system. Now, if you talk about capacity, in general, available with 3 TR to 42 TR, nothing but normally in catalogs, you'll find this in kilowatts because we are using with cooling and heating both now in case of heat recovery or heat pumps. In case of only cooling, you will find this term turn, but mostly in actual practice on the catalogs, you'll find this in terms of kilowatt. So if you don't know the conversion, please make note. 1 kilowatt equal to 0.28 TR. May I ask in interview? 1 kilowatt equal to 0.28 TR. And one more in terms of HP also, you can make a note. 1 TR equal to 4.7 HP.
we are
7 HP.
2 and 1 kilowatt equals to how much?
0.28 TR.
1 TR equals to 4.7 HP.
No, 1 kilowatt equal to 0.28 TR, first point. First conversion. Second conversion, 1 TR equal to 4.7 HP.
Yes.
Similarly, this also important. You can make a note. 1 HP equal to 0.21 TR. Just reverse. 1 HP equal to 0.21 TR. Nothing but 1 divided by 4.7 will get 0.21. So the next topic is very, very important for interview point of view, as well as for a HVAC design engineer. You must know what is FCU, what is AHU, and what are the different types of FCU, what are the different types of AHU, so that at the time of taking the decision, when we are selecting the system, this will help you. And if you want, you can please make a note of this. You see, this FCU and AHU is an 8-side unit, and this is common for split. I'm not talking about both, just in general at this level. After learning this, you'll get the clear idea. So if you talk about FCU and AHU, you'll find in a split system, ductable split, VRF, and the chill water system. And if you talk about district cooling system is also a chill water system, but the chill water system for a community. Okay, so even for district cooling system, this is applicable. And apart from this, if you talk about the geothermal, in that case also you'll find this unit. So this unit is common almost for all the system. I'm not talking about both. For example, if you talk about split system, you'll not find AHU. I'm talking about mini split. If you talk about ductable split, then you'll find the AHU. Similarly, if I talk about the cassette itself is a cassette split system. It's in that you'll find FCU only. There is no question of the AHU. So depend as per the type of system. So after learning this, you'll get the clear idea, and this is very, very important. So the first point, you see AHU and FCU. In short, we used to call it's the air handling unit and the fan coil unit. And both belongs to air side system. If you divide this HVAC system, you can classify into 3 categories. One is a refrigerant system. Second is a chill water system. Third is a air side system. So refrigerant system already we discuss, vapor compression cycle, and we discuss with the different systems. Chill water system you'll find in district cooling system as well as in chillers, air cooled and water cooled in detail. And then the next is air side system. In air side system, you'll find this AHU and FCU. And again, if you talk about eight-side system, you'll find CAV system, VAV system, dual duct, etc. That also we'll discuss. Let me complete this. So you can find on screen, you see FCU and AHU are both commonly used to regulate what temperature and the quality within a building. And remember, this is related to the air side system. So first we'll talk about FCU, then we'll deal with the AHU. Or if you compare this FCU and AHU, you can consider FCU is a smaller unit and the bigger unit of FCU or the bigger version of FCU, we can consider as AHU, just for learning point of view. But concept point of view, both belongs to air side, both is used for cooling system or can be used for heating system, depend on the type of coil or depend on the type of system is connected to. If that FCU is connected to the chiller or the VRF, chiller means you can expect the cooling. If it is connected to the boiler, you can expect the heating. Or if it is connected to VRF system, in the last session we discussed now, if it is a heat pump, you can expect cooling or heating as per the requirement, any one at a time, or heat recovery simultaneously. So this is common. First, let me complete this FCU. So an FCU is a localized unit. Localized means we can consider as a single unit to condition air in a specific area or a zone within a building. Compare with the AHU. AHU can be used to supply the air for multiple spaces, but AHU is for one space. FCU are generally installed near the area they serve, such as wall mounted, floor, or ceiling. And you already have the idea. We discussed about the split system at the time. The different types of indoor, nothing but the FCU. That a high wall is on the wall. We have a floor type also. I'll show you in today's session. And you know about the ceiling. Ceiling is a cassette. Example for the ceiling is a cassette, right? So here on screen, you see FCU in HV system come with a various type and configuration to suit the application and the building need. And most commonly, this FCUs as per the interior requirement or the architectural requirement, because you see, finally, the client is looking for the good interior. So most of the time, the selection or the type of FCU is done by the interior. So they ask you to follow a particular type of interior that suits as per the interior requirement. Okay, so most of the time in actual practice, you'll get this information from the architect or from the interior. In a particular type of project, you need to follow this type of FCU. The system can be a different type, but here I'm talking about FCU. Okay, so it can be depend as per the building type, layout, and the specification, most commonly as per the interior requirement. Remember this point. Here you see the components. What are the different components for FCU? Very simple. We already discussed this, evaporator coil, fan, heat exchanger coil. It is a evaporator here. In this case, if you talk about cooling, if you talk about heating, it may be what condenser, if it is a VRF system, or if it is connected with a boiler. So this can be a heating coil. So in short, in general, we can call as a heat exchanger. Next, the fan. There's a fan casing inside. You'll find the fan motor. It can be two casing. It can be one casing with a one fan motor, with a two fan motor. Depend as per the capacity and as per the configuration and as per the make also. You'll find the fan motor and the filters. And you see, here is a cooling coil. You know this with a bunch of fins. These are the two fan blower. In between, you'll find motor with the two shafts. And here, in this case, if it is a two pipe, you can call as a two pipe FCU. If it is a four pipe, we have four pipe FCU. I'll give you the list in the next page only, the different types of FCU. So this is simple. You can able to understand this because from the beginning in chapter 5, we discussed about the different system and we deal with the different indoor types. So you know about this FCU. So we'll discuss the types, but before this, the major difference between the FCU and AHU, as I said, is the capacity. So if you talk about FCU, you see the capacity is up to 2000 CFM. And you know what is CFM? If you don't know, please make a note. It's a cubic feet per minute. It's a unit of flow rate in English system. It can be liter per second or it can be meter cube per second. The detail we'll discuss at the time of ducting air side in part 4 of this course. So there's different parts as I've given the information at the beginning of the session. So one more point here, you can make a note. 1 TR equal to dash CFM. I think you know this.
400 CFM.
Yes, 400 CFM. And this is standard. This may vary as per the requirement based on the calculation. But if you talk about standard and for interview point of view, or if you talk about equipments, standard equipments designed with this flow rate, 1 TR equal to 400 CFM. So
This is
capacity,
rule of thumb, right? 1 TR equals to
not
4.
exactly rule of thumb. You can consider this as a standard. At the time of calculation, you can consider this as thumb rule, but for the manufacturing or for the equipment side, many manufacturers considering this as standard 1 TR equal to 400 CFM for the common application, not for the precise precision air conditioning or for special type. If you talk about residential, commercial, general application, you will find the equipment with the standard flow rate for 1 TR equal to 400 CFM. So you cannot say completely thumb rule. This we get as a standard. So capacity up to 2000 CFM. Then if you talk about residential FCUs, 0.5 available with 0.5 to 3 TR, nothing but 200 to 1200 CFM. Generally, FCUs or HU we are considering in terms of CFM because the air side unit, the outdoor unit, condensing unit, or the chiller we are considering in terms of the capacity. It can be a ton or kilowatt or HP, but the indoor units generally we are considering in terms of CFM. Okay. Next, if you talk about commercial, 1 to 5 TR, nothing but up to 2000 CFM. May I ask an interview? So remember, FCUs are available up to 2000 CFM. Okay, start with the 200, very small unit. Next, we'll talk about the different types of the FCU. The list I have given. I'll show you the images of each of this type. You'll get the clear idea. So you see the first in the list is a horizontal conceal FCU. Conceal means which is not visible. You see what we discuss in a split system like high wall, cassette, freestand, all comes under decorative type. Conceal, let me show you the image, you'll get the idea. This is a conceal FCU. You see, just will connect a piece of a duct, not complete ducting. If the capacity increases, we can deal with the ducting for the small room also, but not for the multiple rooms. Okay, so this is generally above the false ceiling, which is not visible in case with false ceiling. Without false ceiling, it may be visible in case of some stores, etc. But in hotel rooms or in residential villas, this is going to be concealed. And this is a supply mouth, and you'll find a piece of a duct which will connect to or which will run up to gypsum board, the false ceiling. And on the gypsum board, you'll find a grill. At the time of air side, I'll show you more detail about the grills or the A terminals. At this level, just try to understand the different types. So this is a horizontal conceal FCU. Next, we have a vertical conceal. Again, if there is no space above the false ceiling because of some site condition or interior requirement, we have this alternate option. You see, this is a vertical conceal. You may find the other side of the wall and it's going to be on the floor. And you see, this is not decorative, so it's a conceal. So which should be hidden. And here we can connect a piece of duct, small duct, and with a grill, the air can supply in the space. Okay,
So
but remember, this can be connected to the DX system or can be a chill water system. All these FCUs, okay, except some. All this FCU or AHU can be a part of a DX system or can be a part of a chill water system. So don't think that this single unit will provide the cooling. The outdoor unit is required. Yes, online.
the exact uses of this vertical conceal FCU.
In case if there is no clearance about the false ceiling because of the interior requirement, we can use this one. Or
So
else
below part will be below floor level.
How you can find on the image, you can consider this as a floor level, or it can be used for the double height areas.
Okay.
For example, consider a floor, okay, and this is say 20 or 30 feet height. So, and there is no option for, and you see double height means we cannot use, or there is no false ceiling, for example. So we'll make a partition here like this, and we place the unit and a piece of a duct which will connect to the grill here and the supply air through this. And there is no one reason, depend on the different reason. So this is one example. Similarly, if there is no false ceiling and the unit and even the high wall or the high wall which is on the wall, you know this, it's not accepted by the interior or the client. In that case, we can use this one. Okay, so no, not commonly, you will not find this commonly. This is one option. Very rare you'll find this one. You see here, just we're talking the different types, but all will not use all the time, depend on the case. So you should have the solution. If you know the different types, then you can give the solution based on the different case. The case may be because of the interior, because of the space, etc. Next, everyone know about this cassette. We discuss in detail this cassette FCU,
Yes.
right? Next, we have a high wall. You know this high wall also. We discuss in
Yes.
detail. Next, we have a ducted FCU. Ducted FCU means we can use the duct. Example, you see.
Meticulously.
And don't think that ducted FCU means it is used to supply for multiple spaces. You know the capacity of the FCU is limited, na? So it can be for one space for even distribution of air. Okay, so you can find the unit here, and this is a canvas cloth and which will connect to the duct. And this canvas cloth is used to reduce the vibration from the unit to the duct. And more
The
about this
image
ducting side. What happened?
for image it is not. I'm not able to recognize the unit.
This unit, this side, this sheet metal you can see, no? And you can see the mouth. So it's a conceal, like a
Yes.
conceal horizontal ductet. Sorry, conceal horizontal. What I've shown at the beginning. The same unit will connect with the duct. For example, the capacity say 3 TR, and it's a big room. So in that case, we can use this duct for uniform distribution. So it's a ducted FCU. Next, we have a floor mounted FCU. This is a decorated type. This also not commonly used. You see, very rare with a few models only. And technically also, it is not at all recommended to supply the air from the low levels because the cool air is dense. In case of heating, this is a good option because hot air density is less. If you supply from the floor level, because of density, as density is limited, it can go up and it can heat the air, heat the room. But this is not at all recommended for the cooling purpose. But anyhow, it's an option available in market as per the requirement one can use. This is a decorated type, floor mounted only, but decorated type compared with the previous. Next, we have ceiling suspended FCU. You see, this also very rare. You'll find this is almost outdated. In some cases, you'll find this one, but it's look very odd. But in some makes, you'll find this ceiling suspended also. Next,
Cassette is also ceiling suspended,
yes,
right?
cassette also ceiling. Best option is a cassette. This is alternate of that. In case if you cannot use the cassette and there is no option on the wall, then one can use this one. So you'll not find commonly it's not used. So option. Next is a chill water FCU. You see, chill water FCU or the DX FCU. The difference is the source of the medium. For example, you see in case of chill water FCU, this pipe is a black steel pipe, and in this pipe will supply the chill water, and this should be with insulation. Insulation is not done here. We have a separate topic for chill water system. We'll discuss in detail. At this level, this FCU is connected with the black steel or carbon steel or nothing but this low carbon steel or mild steel, not copper, because this we are using to supply the chill water. So this is a chill water FCU. Means as per the system, this FCU change chill water. And this design also will be different compared with the refrigerant type. The refrigerant nothing but the DX. The next you see DX. DX nothing but what we discuss. You see, this is a copper pipe. And remember, for DX or for chill water, inside you'll find the copper piping only. But the connection for chill water, the pipe which will connect to the unit is different. And the medium, the source of or the medium is different. In case of DX, refrigerant will supply the refrigerant. In case of chill water, will supply the chill water. Next, we have two more, 4 pipe and 2 pipe. 2 pipe means what I explained at the beginning means, but 4 pipe, in the 4 pipe, you will find a separate coil for heating, separate for cooling. So the cooling coil can be connected with the chillers, and the heating coil we can connect with the boilers. Okay, to supply the hot water. So as per the requirement, one can use. So we can call this as a 4 pipe system. Means 2 pipe for this supply it in for chill water, and the other is for the hot water. Again, the model is going to be different. And the 2 pipe, what we discussed at the beginning, the same. So these are the different types of FCU. And as I said at the beginning, this FCU is common for the different system: VRF, chill water, split, ductable split, etc. So this is about the FCU, fan coil unit. In short, FCU. This selection of FCU as per the interior requirement or the site clearance, or mostly as per the interior requirement only, you will find this option. In many projects, initially the interior will decide the type of FCU, and they provide the information to you. Based on that, we'll select. And about the system, that we'll discuss later, how to decide the systems. Even in some project, the system selection also as per the interior, but we need to approve because we need to check the other parameters. That system selection parameter will discuss at the time of machine selection.